Okay guys, a couple of things here before we get started. First thing, I have set the date for your Unit 3 exam. It will be December the 7th. Okay? That's a long way off. We'll be done the unit probably several days before that. Okay, but I always like to give you 2 weeks notice. That is 2 weeks from today. Okay, so that's when the exam will be, but we may have started simple harmonic motion already before we write the test. Okay, and I'm hoping to have simple harmonic motion done before Christmas and be into waves a little bit. Because when we come back, we don't have a lot of days between when we come back and when the exams start. Right, so I think it's like 8 days, okay, when we come back, something like that, 8 school days when we come back, so it's not a lot. So we have to be pretty close to done before Christmas. Okay, just a few things to finish up afterwards. Okay, so for this question here, I think we kind of got started on it yesterday at the end, but we didn't finish it. We are looking for the apparent weight as someone goes over the top of a 150-meter circle, so that means that the radius is 150 meters, the speed is 22 meters per second, okay, and their mass is 75 kilograms. So they're going over the top of this hill. We're looking for their apparent weight, which is what force? Which force? Normal force. Which in this case is acting up and out of the circle. And we have this force, gravity, which is acting down into the circle. All right, since this is a vertical circle, then we know that Fc equals forces in minus forces out. Okay, so that's going to mean that Fc equals Fg minus Fn. We're looking for Fn. I don't like to solve for things when they're negative, so I'm going to bring Fn over to this side by adding it, and then I'm going to subtract Fc. So I'll end up with this. The apparent weight equals the force of gravity minus the centripetal force, which means the normal force will be smaller than Fg. After all, I'm subtracting something from Fg in this formula. Does that fit with how we should feel going over the top of a vertical circle? Yeah, we should feel lighter. Okay, so Fn should be less than Fg. Right? Always good to kind of logic check your math, okay, when you're doing algebra and stuff. Okay, so now that I've got that, now I'm going to put in the formulas. That's going to be m times g minus mv squared over r. So that'll be 75 times 9.81 minus 75 times 22 squared divided by 150 meters. Okay, minus 75 times 22 squared divided by 150. All right, so 4.9 times 10 to the 2 newtons up would be our apparent weight. Okay, everybody all right with that one? That's a pretty typical vertical circular motion type question. Okay, I think I put one pretty much like that on the unit exam last year. Okay, try this one. NASA's Vomit Comet, okay, that big zero gravity plane, okay, that they use. We want the riders to have a feeling of apparent weightlessness, and the plane can fly at 210 meters per second. We're looking for the radius of the circle or arc or parabola that it needs to fly in. So, what part of the circle are we talking about here? Top on the inside or outside? Top on the outside. Okay, so we're dealing with this situation here. Okay, so we're going to have Fn and Fg, except that we're not going to have Fn because apparently we don't, because we're apparently weightless. Okay, so there's no Fn. So really, what we're left with is that Fc equals forces in, gravity, minus nothing, because there's no forces out. Okay, so we're going to have mv squared over r equals m times g, and we're solving for r on this one. So we're going to multiply both sides by r, the m's are going to cancel, g is going to be here, and r is simply going to be v squared divided by g, so that'll be 210 squared, okay, divided by 9.81. All right, so we're looking at 5.0, yeah, 5.00, because we have 3 significant digits, times 10 to the 3 meters. Okay, is that a pretty reasonable number? It is. I mean, this is a plane after all. It's a big circle in the sky it's flying in. It's moving at 210 meters per second. It's going to go a long way. Okay? So yeah, that's a very reasonable answer. All right, how are we feeling about these vertical ones? Okay. How are we feeling about the vertical stuff?
Why did you round that down from 4.5 and 5.00?
It's 4.5.
What's it? Oh, sorry, I was looking at 4.9.
Yeah, it was
Did I just look at it wrong?
It was 4,490.
I was looking at 4.95. Sorry, you're absolutely right. Yeah, 4.50 times 10 to the 3 meters. Sorry, yeah. More coffee. Just have more coffee. Okay. Are we feeling okay about these then?
Could you like one more?
Oh, we're gonna do a few more.
Okay.
Yeah. Okay. So plan is today, guys, is to just kind of expose you to a bunch of different circular motion problems, both vertical and horizontal, and then tomorrow give your assignment on all types of just regular circular motion.
What does the valve cover gasket do?
Valve cover gasket seals the valve, or seals the cam cover on. If you don't have that, oil shoots out.
Yeah, exploded.
Oh, yeah, that'd be bad. Pressure will escape, oil will escape, car will die. There's a circular motion component for the movement of the cam. Rocker arm rotates in a circle, makes valves go up and down, actuates them.
How do you get rod knob?
Rod knock is from poor compression of the fuel. So if your timing is off, so your spark plug fires early, the gas is not fully compressed, and it will push the piston down before it's supposed to go down, and it creates a knocking or a pinging sound.
Are we going to have quizzes and stuff tomorrow?
No, we're not going to have a quiz tomorrow because tomorrow's short. Yeah.
Let's go.
My mom's not taking 100% on the quiz, but I'm going to do my favorite.
I like that. That's incentive.
Yeah.
Did you email her?
Nothing motivates teenagers like car keys and cell phones. And PlayStation.
Yeah. That's all I got to
I have a teenager. I found all the key motivators.
You just find,
Pocket
yeah,
master.
you find what he likes, and then you just.
Yeah,
They
just
will.
find what makes him happy and then destroy that.
Yeah, exactly. I mean, we're parents. We're plastic. It's like that's okay. So in your digital workbook, guys, there are a bunch of these problems that I'd like you to go over. Okay. So I'm just going to bring it up here. Okay, so we've got the vertical circular motion worksheet that starts at the bottom of page 2, okay, that I'd like you guys to start on. Like, some of them are pretty straightforward, okay, like 1 and 2 are pretty straightforward, so, you know, maybe you don't have to do both of those, but definitely do the ones as it progresses in difficulty, okay, on down the page there. Give those a whirl, and there's probably a few Actually, I think we did all the ones on the other ones. So let's work on the vertical circular motion ones here for a little bit. And if we're doing well on those, then we might move on to the assignment today. Okay? We'll see. And then you have part of today and a short class tomorrow to work on the assignment.
I'd like to start with that.
Okay, so student has a weight of 655 newtons, so they're telling us the force of gravity is 655 newtons. Okay, they're riding a roller coaster. The same student has an apparent weight of 1.95 times 10 to the 3 newtons at the bottom of the dip. Okay, so putting in my diagrams here so that I know which forces are in and which forces are out. Okay, and the radius is 18 meters. All right, so what's the speed of the roller coaster? Okay, so Fc equals forces in minus forces out. Okay, the one thing I don't have that I'm going to need is the what? But I do need that because that's the question asked for. Before I can get that, I got to get what? Mass. Can I get that from the weight? Yeah, absolutely. So it's going to have to get the mass. That's just going to be the weight divided by 9.81. So 655 divided by 9.81 gives us our 66.77 newtons.
You mean kilograms?
Sorry, kilograms. I do mean kilograms. You know what I meant, not what I wrote. That thing. Okay, so for this here, we've got Fc equals normal force minus force of gravity. Okay, and we are looking for the speed of the roller coaster. That's going to be mv squared over r equals 1.95 times 10 to the 3 minus 655. Okay, we're going to manipulate for v, so I'm going to bracket that and multiply it by r, and then divide it by m, and then square root it, and that will get me v. Okay, so we're looking at 1.95 d3 minus 655 times the radius, which was 18 meters, divided by that number right there, the mass, and then square rooted. So we're looking at 18.8. I don't know why I got 18.8 up there. I got 18.7. I must have rounded it off somewhere. Yeah, so 18.7 meters per second. All right, any other ones? Okay, why don't you guys take a quick break here, and I will hand out the assignments. You can get started on those, and we'll take more time tomorrow. You may.